Young Kuo. He's a professor of Biomechatronics Engineering in National Taiwan University. He is expert in agricultural automation and machine vision for automation, and he leads the machine learning and machine vision lab at NTU. He has done excellent research in integration of AI and precision sensors into a variety of smart ag systems. So today he'll talk about AI in agriculture, from disease identification to Q&A with tomato as an example.
So thank you very much, and it's my great honor to join this workshop. I think this is a warm, but not so many people, and I think that this is a very good occasion to share with each other our research work. And today, my topic is a little bit different from phenotyping. Basically, I will focus on crops, but from another aspect, that is disease identification. And then also, how do we pass knowledge from generation to generation using AI? So this is basically the topic. So this is the synopsis. First, I'll talk about machine vision that occurred in the past 10 years already. And now we have generative AI. And how does it help us? And I have some, I would say, imagination of future agriculture, and I would like to share with you. So let me start from the very beginning, food production. So our mission is food production, that is for sure. And agriculture is vulnerable to many things like weather, plant disease, and etc. But in the past decades, centuries, we developed machines, and we use greenhouse to overcome these issues. Still, there's one thing that we need to overcome. That is like the knowledge or experience from farmers. So farmers, they still have to go to field and check the quality of their crops. And this not only requires their time, but also requires the knowledge. And in the past time, the knowledge is delivered from generation to generation. But nowadays, we have some issues, and how do we overcome this problem? So we can use AI. So basically, AI to us is a tool. And I'm not sure in your country if this is an issue. In Taiwan, the birth rate is drops so quickly that the nowadays current birth rate is only like 1/3 of the year that I was born. And even though the birth rate is not dropping, the labor of agriculture is dropping in developed countries as well. So back in 2016, the Ministry of Agriculture in Taiwan proposed a big project. So as you can see in this figure, that this is called smart agriculture. So the idea is like this: we have people that is in the field originally from here, and we use sensors to sense the information, physical or chemical, using IoT sensors over here, and send it to cloud. And we have AI in the cloud that can do the calculation. So smart agriculture, to me, that is AI plus IoT. So we say AIoT sometimes. So basically, it's a big picture of everything. But let me separate AI from into two. One is machine vision, and another is generative AI or text AI. So let's review what has happened in the past. I will use tomato as an example because it's a very important crop worldwide, and so we know it's very popular everywhere. And so the purpose of developing this AI is to help the farmers. So how can we help farmers? How should we start? That's always a big question. There are two ways to to check what disease it is, like microscopic examination, that you require microscopic, and you need like dish culturing and a lot of procedures. And another is that you use your cell phone to take a photo and send it to to an expert and ask what is going on over here. We choose the later one, this one, the star one, because it's more accessible to the farmers, okay? So that's our purpose. And we actually, next question is we need to determine where we should start. Like before a plant or say a fruit is start to grow, we can see the plant and the plant can get diseased already. So we definitely will choose leaf. And so we don't choose fruit because sometimes it's not available, but plant is sick already, and we can choose stem. But for the root, it's not a good choice. You have to eradicate that plant, and it might be dead already. So then we start from the leaf. That's the very beginning idea, very first idea. And next is how complicated are disease? It's very complicated. It's not only disease, pests, and also disorders. And so this is for tomato. You can see 17 EPDs here. But we have more than 17. I only did 17. We have more than 17. And another issue is that for some disease, they're at early stage. So these are early. They're so early. And when I ask the experts, can you identify them? They say, no, sorry. They can't. Even for the plant pathologists. So how do we deal with that? So how do we identify them but without compromise? That's a good question, right? So we come up with the idea that we group some of them together. But how can we group them together? Because they can share the same pesticide. That's the key. I think we have AI that is very powerful, and we have the old methodology to identify plant disease. But in order to apply AI on plant disease identification, we have to close the gap between plant pathologists and the agricultural engineers. That's the key. That's the key to succeed. So in order to do so, I call it the multi-agent AI. I use 5 AI models, machine vision models, 1, 2, 3, 4, 5, and I will explain this in depth details. And this is the numbers of leaf images that we collect in the past 6 years. Actually, we collect more than 20,000 already, but some of them are not annotated yet. So these are for the 17 different diseases. So very first model, the model number 1, is an anomaly detection model. So if you if you don't use anomaly detection, and if you give AI model this kind of image and ask what it is, it will choose one from that 17 disease, and that will give you the wrong answer. Once the farmers they receive the wrong answer, they won't use your AI anymore. So this is the most important key, anomaly detection. You tell the farmer this image is not qualified, you have to retake it. That's the key. Second is that we have to, first do some internal check what kind of leaf image this is. So we have 2 kinds. One is compound leaf and another is leaflet. But separate them because one is like a microscopic issue and the other is macroscopic. They have different labels and we have to identify them first. And so this is for the compound leaf. We have health, virus, and phytohormone damage. That means too much phytohormone. So this is very obvious on compound leaves. And the next model, number 4, that is the leaflet diagnosis model. So here you can see we are doing a very fine check of what is going on in the leaf, what are lesions we have in the leaves. So this is number 4. And number 4 has a very good advantage that we can identify several diseases on the same leaf using one model. But the annotation is very costly, very time consuming. And then we can do some further, interaction with the farmers. We can ask farmers to flip over their leaf, because some symptoms, they are not obvious on the top surface, but they are very obvious on the bottom of leave back, leave front. Okay. So this is actually we have achieved in the past 5 years. I would say that once we have some model that has accuracy more than 90%, it is usable. It is usable. So we integrate this with a instant messenger software. It's called Line. All right. So that has become, well, I would say computer vision. Although we still need it, but it's pretty mature already. There's nothing new. But the way is like, I think the key is the way that you apply machine vision model. So next, language processing. Language processing. So what problems, what issues do we encounter? We encounter expert exhaustion. I'm not sure the architecture in your country, but in Taiwan we have extension stations. They have experts. They provide service to farmers, answer their questions. And I know in the United States, extension is actually part of the job for professor in the school. And either way, there'll be like service provided to the farmer. But we are short of manpower everywhere, and there are so many issues, new issues coming out. And now we come up with the idea, or say, it's the era of generative AI. We know large language model can do so many things. So can we use large language model to answer farmers' question, or say in the United States, they call it E-extension in the past 10 years. Now we call it like a LLM extension. So I'm not the first one come up with this idea. But what's the issue of this service? Hallucination. So what is hallucination? When we train a large language model, it learns from a lot of data, gigabytes of text, and it learns something that it doesn't know what it is, but sometimes it just comes up with an answer that is not accurate, or say 100% correct. And that's called hallucination. So how do we prevent this hallucination? Our best bet is called RAG, the Retrieval Augmented Generation. So here is actually a search engine and a large language model. So the farmers ask a question, there's a query, and we feed the query into the search engine. And we have some document over there, and then we retrieve the related document. And then we feed that question and the document together into large language model, and ask the large language model to understand the document, then give the farmer the answer. That's called RAG. That's so simple. And here in NTU, in my school, we developed a two-stage retrieval. Two-stage is actually quite common. So we have stage 1 over here, and this is stage 2. So in stage 1, we will use an embedding model. That is actually an encoder that will map a question or one document into a hyperspace. Imagine that it's a point in the hyperspace. And you have a document that is very close to your question. That means those two are related, strongly related. So that's the first stage, you call it top-end document. Then second stage is called re-ranker. Re-ranker is a model that you compare the document with the question one by one. It's a very slow calculation. So here's the performance of the retrieval. In this test, we actually do not use document in agriculture. We are still working on that. But you can see that with our approach, that we can reach a very good MRR with a reasonable response time. Re-ranker is very accurate. You can see that. But the time it requires is actually quite long. So we prefer this method. So here is a short demo of what we have here. Oh, let me see. So this is basically web open UI. Well, model not select, sorry. I think it's very easy. Everybody can set up your own RAG easily. And I just give a question over there, and we have to wait for a few seconds because my GPU is not very powerful. Sorry about that. Okay, it's all about money. If there's no money, there's no talk. All right. So the best thing that when we do our own reg, we can. Sorry, this is in traditional Chinese. So we can know the resource. We identify resource, and if we have our farmers or expert has further question, they can go check the resource. And this also tells us like the time that requires for this service. So this is based on A6000. I'm not sure if that considered expensive to you or not. So now, what is the future? Well, this is not the future. This is what I see that we can achieve. We can actually use one single service that provides both the text generation as well as the computer vision. When the farmers feed an image, that we use a computer vision model. When farmers ask questions, we use the RAG model. And why don't we use like service from ChatGPT? What's the advantage of people in the area of agricultural engineer? What's our advantage? We know we are the bridge between engineering as well as agriculture. We know the details and we can talk to experts in the agriculture. And why don't we use one single large model instead of we use small models? I don't have an answer, but I think everyone has their own answer. So I will give that question to you. So what I mean like future agriculture. So last day, I have a great honor to visit Dr. Wei Guo's lab, and we see like autonomous tractors running in the field. The tractor doesn't need man on it. It can like go through the field automatically. But what can we do more than that? Of course. So we're talking about like AI agent. So what is AI agent? You give it an order, and it can find the steps one by one and complete steps one by one by itself. So we can imagine the autonomous is not only autonomous like checking the field. It can complete our job by itself in 10 or 20 years. Okay. So this is my team. I would like to acknowledge my students and also my sponsors. And I have to say, I don't have a...
不是，我觉得不容易。
Sorry, too loud. I don't have a very fancy phenotyping facility to show you. I only have coffee. So if you have a chance to come to NTU, please stop by my lab, and I'm more than happy to brew you a cup of coffee. Thank you very much.
Awesome. Questions?
Thanks for a great talk. Actually, I just walked back into the classroom at the second half of your talk because I have to pick up a phone. Sorry for that, but when I come back, I saw your slides was on the the vision language modeling this part. So actually, I also did a bit of work in this area, but I just realized that one potential limitation of this work could be the quantification power of the VLM. VLM is kind of like the have the probability distribution to predict the next token. So we inevitably will make some of the hallucination problem when is associated with some of the quantification problem. So my question is, in your research, did you met this kind of issue? If so, have you managed to solve this?
That's a very good question. Actually, in my research, I do not want to use VLM. I don't think it's actually a big problem. I think computer vision, I use small computer vision models. So I only need, not so big data set. And I can identify plant disease accurately. If I use VLM, they are bulky. You need a lot of data, and you really need to pay attention to make sure that it works well. And instead, I use computer vision for image recognition, and I use RAG to answer questions. And I can put them together. In that way, I can use like teeny tiny models, relatively speaking, but they can work well. And I can make them work easily.
Yeah. Thanks for a great answer. Thank you.
Any other questions? I had a quick question about the RAG model. So, how do you validate this? Do you have a benchmark data set that you validate on, or do you have other human evaluation steps?
I think benchmark is the next step that everyone wants to do. Actually, I visited University of Illinois at Urbana-Champaign last week, and they were talking about benchmarking. And the current way that we do benchmarking is that we use some powerful large language models, say ChatGPT, to read some document and to generate question and answer pairs. But the issue is that for those questions, farmers are not going to ask those questions. Those are fake questions. So we really need some question that those are asked by the farmers and to do the benchmarking. I think benchmarking is needed, but it's very difficult in the sense it's not quantitative, it's qualitative. Because you want to check the text generated by the RAG or the large language model, are they appropriate for farmers, or they are only for experts like us? I think those are totally different. That's really a big question. I think there will be some advance in the following years.
Excellent. So the MRR score that you showed, those are based on these LLM generated questions and
Yeah, currently I'm collecting document from the Ministry of Agriculture in Taiwan, and I believe in 1 or 2 years I'll more than 20 or 30,000 articles from them, and those are like a very good knowledge base for answering farmers' questions.
excellent. Thank you. Other questions?
I'm an extension field agronomist in Iowa, in the U.S., and I work with farmers very regularly. So I don't view this as a threat to my job, really, but it's a little personal. But one of the things that I find is not necessarily hallucinations, but the inability of AI to, I guess, accurately interpret which resources are relevant geographically to a question that a farmer's asking. I'm wondering if you've noticed the same issue and if you're aware of any solutions or working on solutions for that.
Well, that's a very good question. I mean, of course, like for crop cultivation, it depends on the regions. And not only about it, like also for the computer vision, like the plants, say disease, the symptom, the lesions, their appearance are totally different, like in Japan and in Taiwan. So our best bet is actually to use the local data. And so how to define local? I think that's very challenging. Say Iowa is one state of the United States, and I guess, you have corn in Iowa, I guess, because I graduated from Purdue. So in California they have rice, they don't have corn. So I think everything is kind of like different from state to state, especially states so large. And for now, this is like just the very beginning of an application of RAG or LLM. But I think those problems can be solved gradually. I don't think AI is going to be a threat to extension experts. They are going to be some assistant. They are like service like 24/7 online. If I was a farmer, I would ask the AI first. If I don't get satisfied answer, I then contact experts. I think AI is a way to solve experts' time. I would say that's my point of view.
Any final thoughts, comments, questions? Great. If not, let's thank the speaker one more time.